Assalamu alaikum and hello everyone. In this session, we're going to continue with example on how to solve vibration absorber problem. So if you refer to example 6, we have an example of a motor generator. Okay, it operates in the speed range of 2000 to 4000 RPM. Okay, and it vibrates violently at a speed of 3000 RPM. So now, from here we know that 3000 RPM is the resonance frequency. So we know that resonance frequency is when the natural frequency of the system is equal to forcing frequency. So we know from here that 3000 RPM is omega, which is the forcing frequency, and it also equivalent to the natural frequency of the system. So in here, in order to tackle this issue, right, so the designer have used a 2 kilogram trial mass, and when it's tuned to the resonance frequency 3000 RPM, okay, so this trial absorber produce natural frequency of 2500 RPM and 3500 RPM. So from here, we know that when we use 2 kilogram as the trial mass of the absorber and we tune it to 3000 RPM, which is the resonance frequency, it will produce a new natural frequencies of 2500 RPM and 3500 RPM. So now the question asks you to design the absorber to be attached by specifying its mass and stiffness so that the natural frequencies of the system fall outside the operating speed range of the motor generator set. So in this example, we can see that the designer tried to use 2 kilogram as the trial as the mass of the absorber, and we can see that in here 2500 RPM and 3500 RPM, okay, both of these value is still within the range of the operating speed. The operating speed is 2000 and 4000 RPM. So from here we know that we cannot use the 2 kilogram as the mass of the absorber, but this trial absorber is actually give you a hint, alright? So this allow us to determine the mass of the system, because if you see in this example, it doesn't give us the mass of the system M1, right? So basically, when we use 2 kilogram, okay, we got this natural frequency, and from here we can find the M1 first. And then once we determine the M1, right, the mass of the system, we can determine mass 2 and K2, right? So this is the example of the motor generator. So it used in here, if you can see vibration absorber here, right? So it gives us the, so when they try to put 2 kilogram in here, so basically we can use that information to find mass of the system, which is the motor and generator. So let me copy this for a while. All right, so how we're going to solve example 6. First, we write there all the information. So operating speed, so it's 2000 RPM to 4000 RPM, and then we know that the resonance occur at 3000 RPM, and when it use trial mass trial, 2 kilogram. Okay, we got two natural frequency, which is first one is 2500 rpm, and second natural frequency when we try to use the trial mass is 3500 rpm. So please take note that when we put 2 kilogram, we got this 2500 and 3500 rpm. Basically, we cannot use 2 kilogram in here because 2500 and 3500 is still within the range in here. Okay, basically when we want to design absorber, we must make sure that the absorber lies outside. So when it means lie outside, it means that our natural frequency of the absorber must be below than 2000 rpm, and second one must be over 4000 rpm. So this is the concept of vibration absorber. So in here, as I mentioned, this one gives us the opportunity to determine the mass of the system, which is mass 1. So what the question asks us to do is that to design the absorber, so basically we need to find K2 and M2, which is the absorber. Yeah, when I mentioned K2 and M2, so this is the parameter of the absorber, and we must make sure the new natural frequency is outside the range, meaning that it must be, so this one must be less than 2000 rpm. 2000 rpm is referring to the operating speed, and sigma 2 and omega 2 is more than 4000 rpm. So how are we going to solve this example? So first thing, what we need to do is we determine the omega in radian per second. So omega is equals to 3000 divided by 60 times 2 pi. So we get 342 radian per second. So meaning that this is the forcing frequency which cause resonance to occur. So next, we need to determine, we need to convert this value first, okay, to radian per second. So sigma 1t. Okay, why do we need to do all this? Because it's easier to work in radian per second. So divide 60 times 2 pi is equals to 261.8 radian per second, and sigma 2 trial is 3500 rpm, so over 60 times 2 pi, so it's equals to 366.5 radian per second. Okay, so it's better to convert all of the values in all of the parameter in radian per second first. Okay, so now in as I mentioned, in order for us to determine this K2 and M2, basically we need to find M1 first. Okay, and then from M1 we can use mu to determine the M2 because we know that mu is equals to M2 over M1. Okay, so how do we find the mu? In order for us to find the mu, we need to determine the R. Okay, so refer to your lecture notes. Okay, so basically we need to find R first. Okay, and then from here, once we determine R, okay, we can determine the rest. So now we know that R1, okay, which is referring to the trial, okay, because we know that R is the ratio, frequency ratio between the absorber frequency and the forcing frequency. So we use 2500 because basically we want to determine the mass 1. So and basically we need to determine this one. So 261.8 over 314.2. From here we can get the frequency ratio of R1, which is 0.833. If let's say you want to use RPM straight away, because it's a ratio of the frequency, so you can also use 2500, which is the natural frequency when we use trial mass absorber of 2 kg over 3000 RPM, and basically we'll still get the same answer. Okay, so once we have determined that, okay, we can determine the mu. Okay, mu is given as R1 to the power of 4 plus 1 over R1 to the power of 2 minus 2. So 0.833 to the power of 4 plus 1 over 0.833 to the power of 2 minus 2. We got 0.135. So this is the mu, okay, when this mu is actually mass 2 trial over mass 1. Okay, why mass 2 trial? Because we are using the natural frequency of the trial absorber, which is 2500. So 0.135 is mass 2 trial over mass 1. Okay, basically we want to determine M1. So M1 is 0. M1 is 2, okay, 2 kilogram, which is the mass trial, over 0.135, and we get 14.73 kilogram. Okay, so as I mentioned, when we use 2 kilogram in here and use this natural frequency trial, we can get mass 1. Okay, so now once we have determined mass 1, okay, we will move to on how do we find the absorber parameter. which is M2 and K2. So in order to obtain all of these values, okay, first we need to determine, so maybe I write here, to determine mass 2 or the mass for absorber, we need to determine R1, which is referring to operating speed. Okay, so the operating speed, we know that it is 2000. So R1 absorber is actually natural frequency over omega. So what is the natural frequency? The natural frequency here is given as the operating speed, which is 2000 RPM. So 2000 RPM over omega is 3000 RPM. We get 0.667. So from here, we can determine the mu, okay, which correspond to this natural frequency. So R1 absorber to the power of 4 plus 1 over R1 absorber to the power of 2 minus 2 is equals to R1A is given here 0.667 to the power of 4 plus 1 over 0.667 to the power of 2 minus 2, we got 0.694. So basically, why do we need to determine this R1A and mu? We have already determined the mu before in here. Okay, take note that this mu we get when we use 2 kilogram. So now, and we know that when we use 2 kilogram, okay, we got the new natural frequency of 2500 and 3500. And this 2500 and 3500 is still within the range of the operating speed. So basically, we cannot use this mu to determine the parameter of our absorber. So this is why we use the operating speed natural frequency in order to determine the mu, and once we determine the mu, we can find the M2. Okay, so now we got the mass ratio of 0.694, and we know that mu is actually mass 2, which is mass 2 is the mass absorber. Okay, put mass 2 or absorber over mass 1. We have already obtained mass 1 from here, which is 14.73 kg. So now we want to determine this. So mass 2 or the mass of absorber is actually mu multiplied with m1. So mu is 0.694 multiplied with 14.73 kg, and we got mass 2 as 10.227 kilogram. Okay, now we have already obtained mass 2. Next, we need to determine K2. Okay, because parameter of absorber is basically K2 or K of the absorber and the mass of the absorber. So how do we determine K2? We know that omega 2 is equals to square root K2 over M2. So we have already obtained omega 2 because we know that omega is actually omega 1 and it's also equals to omega 2 in order to solve the concept of absorber. So we have already obtained mass 2. We already know omega 2, so we can determine K2 straight away. And K2 is given as omega 2 squared multiplied with mass 2. So we need to know that when we want to find mass or K, we must make sure the omega that we use is in the unit of radian per second. Okay, that's why I really encourage everyone to convert first to radian per second, because if we use RPM, so the unit is totally different. So omega 2 squared is given as, we already defined it earlier, it is 314.2 radian per second. So 314.2 to the power of 2 multiply with M2, which is 10.227. So we got the value of 1.01 times 10 to the power of 6 Newton per meter. So from here, we have already determined all of the parameter. Alright, so are we done now? Okay, actually we're not done yet, because we must make sure, okay, the omega 1 and omega 2 of when we try to put the absorber is outside operating speed. Okay, because the question asked us to make sure that uh, the, the absorber that we use, okay, produce natural frequency which is outside the operating speed. So we need to work backwards. Okay, so now we need to determine R1 and R2. Okay, R1 and R2 when we use this absorber. Okay, so basically we will get R1 and R2. Why do we need to determine R1 and R2? Because from here we can determine, once we got R1 and R2, we know that R1 is equals to natural frequencies that is produced by the absorber over omega, and natural frequencies, the second one, over omega. So basically, this is the thing that we want to make sure it is outside the operating speed. So from the equation, we know that R1, R2 squared, okay, is 1 plus mu over 2 minus plus, okay, just remember minus plus is not plus minus, 1 plus mu over 2 minus 1. So first we need to determine R1 first. So R1 is given as 1 plus mu over 2 minus square root 1 plus mu over 2 to the power of 2 minus 1. Okay, so which mu that we're going to use now? The mu that we're going to use is the mu that we have obtained in here. okay, because this is the one that corresponds to mass 1, and it also gives us the value of mass 2. As I mentioned, we cannot use this mu because this is when mass 2 is equals to 2 kilogram, which is the trial, and this trial will produce natural frequency that is within the operating speed. Okay, so that is not the correct mu that we need to use. Okay, so this is the mu that we're going to use. So R1 squared is equals to 1 plus 0.694 over 2 minus square root 1 plus 0.694 over 2. Okay, please remember in here there is a power of 2 minus 1. Okay, don't do careless mistake. And this is equals to 1 plus 0.347 minus square root 1 plus 0.347 to the power of 2 minus 1. So 1.347 minus square root of 0.902. We got 0.397. Please note that this is R1 to the power of 2. So to determine R1 is actually square root of 0.397, and we got R1 equals to 0.63. Alright, so now that is for R1. Okay, how about R2, frequency ratio of the second natural frequency? So the second one, R2 squared, is equals to 1 plus mu over 2 plus square root of 1 plus mu over 2 squared minus 1. So now it becomes 1.347. Okay, you don't need to calculate again because in here, okay, it's actually same with here. Okay, and this one is actually same with this one. Okay, the only difference is the sign. Okay, for R2 we use plus, for R1 we use minus. So this becomes plus square root of 0.902, and we got 0.397. Sorry, we got 2.297. So R2 is square root of 2.297, which is equivalent to 1.515. So once we have already determined R2, R1 and R2, and from here we know that R1 is sigma 1 absorber over omega. So what we want to determine now is here, because we already know what is omega and R1. So this one is actually R1 omega, which is equivalent to 0.63 multiplied with 314.2, and this is equivalent to 197.95. Note that the unit is radian per second. Okay, so when the unit is radian per second, because the operating speed is given in RPM, so we need to convert this. So in order to convert this, okay, you must find it in RPM and give us value of 1890 RPM. Okay, so if you see now, the new natural frequency when we use mass 2 of 10.227 kilogram, we will get this. The first natural frequency is 1890. 1890, if you refer to the operating speed, is 2000. So this already fall outside the first range. Okay, now let's determine the second new natural frequency, and we must make sure that it must be above 4000 RPM. Okay, so from here we know that R2 is omega 2 over omega, and omega 2 is given as 1.515, which is R2, multiplied with 314.2, and we got 476 radian per second. And we must convert this to RPM. So 476 over 2 pi multiplied with 60. Okay, so we got 4545 RPM. So when we use the mass 2 of 10.227 kilogram and we use 1.01 meganewton per meter for the stiffness, we will get the new natural frequencies of 1890 and 4545 RPM. And the operating speed just now, the original operating speed was 2000 to 4000 RPM. So 2000 and 4000 RPM. So from here we can ensure that the absorber will be working effectively since the first natural frequency and the second natural frequency is outside the range of 2000 and 4000 RPM. Alright, so that's all for this session.